Okay, so now we're going to talk about our measures of central tendency, right? Central measures of tendency. What that means is middle. Going to try to find some middle of our data, right? And why? Why is it meaningful? Well, you can kind of liken it to getting a score back on your test, right? So you get a test back and it's a 79%, right? And when you're trying to decide how you feel about that, I mean, on its face, you may not love the fact that you've got a C plus, right? Because that's kind of where 79% falls. But when you run off to college, and maybe even some classes here at the high school, you may encounter some teachers that will curve a test, right? So your 79% is what it is, and you feel the way you do about it. But inevitably, when I hand back a test, one of the first things I get asked was, what was the average, right? What was the class average? And now you're wanting to know, how does your score stack up against the rest of the class, how the rest of the class did, right, as a group. And so the class average is a measure of central tendency that gives us an idea of, on average, how students scored. And so now, if you find out that the class average was a 65%, then your test score starts to look a little bit better, right? Or if the class average was an 85%, then your test score maybe doesn't look as good as what you may have originally thought, right? So it's all relative to the rest of the data. And so three measures of central tendency: mean, median, and mode. And they all have kind of different connotations and different times where we're going to want to use them, right? So the first is the mean. The mean just means average, right? It's the average of all of our data pieces, okay? You calculate the average like you always have. You add up the number of numbers that you have, and you divide by the number of numbers that you have, right? So it kind of sounded weird to say it that way. Now, one thing you need to understand is that the mean of a population and the mean of a sample are two different things, right? Very often we'll use the mean of a sample to try to guess the mean of the population. The mean of the population is what we're going to want to know. Unfortunately, we're not going to know it very often. It's very, very difficult to get the mean of an entire population. Most of the time, it's way too difficult to find a measure on every individual in a population. But there are times when we can do that, right? If I want to know what the mean of the population mean, well, if I find the mean of a test that I give in a class for all the classes, then I'll have my population mean, right? My population would be all of the students in that particular class. So let's say our trig class from last semester. If I wanted to know the mean of one of my trig tests, then I would just use all of the test scores in the 4 classes. That would be a population mean. So sometimes the population mean does exist, and it's easy enough to find, but most of the time not. But at any rate, what you need to understand out of this is that mu, that's pronounced mu, the Greek letter mu, is what we use to denote a population mean, right? This is if we calculate the mean for our entire population. And this notation, that sigma, it's a Greek letter sigma, just means summation, which means that we're going to add up all of our data pieces. So in the example of the test scores, you're going to add up all the test scores, right? And then we're going to divide it by the number of test scores that there are, right? And again, we know how to find the average. But the mu is kind of a new notation, and so is that sigma maybe. It just represents the population mean, and the sigma means that we're going to add stuff up, right? Now, a sample mean, like I said, most of the time we're going to be dealing with sample means because sample means are easier to obtain. We're going to get a sample, collect our data, and then we can start calculating the average of that data if it's a numerical or quantitative data, right? X bar is how you read that, right? X bar is what we're going to denote a sample mean with. And so since a sample mean and a population mean may be different numbers, we need to make sure that we're using the right symbols to talk about the right thing, okay? But again, everything else is the same. We're going to add up our data entries and then divide by the number of data entries that we have to get our mean, to get our average, right? So, for example, I interviewed 8 random students and then asked them how many hours of TV they watched last night. And here are the results of those 8 students, right? If we're going to calculate the mean, right, this is going to be, since it's just 8 random students, this is a sample, so we're going to come up with a sample mean. All we got to do is add up the number of numbers, so add up the number of hours that were watched, 5, 4, 3, 3, 2, 1, 5, and 3, and then divide by 8, because that's how many data pieces that we have. And that'll get us 3.25, right? So that means that on average, the students interviewed watched 3.25 or 3 hours and 15 minutes of TV last night, okay? That's kind of what a mean tells you. On average, what your sample did, right? Now, let's say that we asked a 9th student, and the 9th student watched 10 hours of TV last night. It was a complete veg night, and they watched 10 hours, right? Stayed up until 1:30. It's nuts. But what happens to our mean if we include that what is basically an outlier, right? It's an unusual individual data piece within our set, right? What happens? Well, now we're going to add up our 9 numbers and then divide by 9, and our average becomes 4. So now instead of, on average, the students in our sample watching TV for 3 hours and 15 minutes, it went up by 45 minutes. And now the students interviewed watched, on average, 4 hours of TV last night, okay? That's, 45 minutes in the grand scheme of your time in the evening is not insignificant, right? What could you do in that 45 minutes? A lot, right? So that 10 really affected our mean, right? It really pulled our mean over. So while the mean is a pretty easy number to get to, it's easy to understand, the problem with it is that it is severely affected by unusual data pieces, outliers, right? That could really affect our calculation. So if we have a couple of outliers, then now we're talking about moving our measure of central tendency by enough that maybe it's not a good measure of central tendency anymore, right? Now, median and mode. Again, these are things that you talked about since you were in the 4th grade, right? Median is just that data piece where half of the observations fall below it and half of it fall above it, right? So in this data piece, we're going to line them up, and then we're going to go find that middle number, right? And we kind of start crossing these off from either end. And you saw this in the stem and leaf plots from before. And 3 ends up being that middle number, right? So the median here is 3. Now, when you add the 10th data piece, the 9th data piece, that was 10 hours, right? Remember how it really affected our mean? If you do the same thing here, now we have 2 numbers that are in the middle. Now, when that happens, quick side note, do you remember we just add these 2, divide by 2, we average these 2, which is still going to give you 3. So our median is still going to be 3. So our median was unchanged by that outlier, okay? Mean was changed a lot. The median was unchanged, okay? So you're getting into a table now of advantages and disadvantages, and that's what you want to talk about. The mean is easy enough to calculate. It means a lot, right? We understand the mean a little bit more. We understand what it means. Like on average, this is what happens. The disadvantages, outliers really affect it, right? Now, median. Advantages, outliers don't affect it, right? If you get a bunch, then it starts kind of pulling our median a little bit, and it depends on where the outlier sits, on which side. But for the most part, the median is not going to be affected by our outliers. The disadvantage is you have to line up the data, you have to count them off, and it's a little bit harder to come up with, right? Now, mode. We need to go back. Mode. Do you remember what mode is? Right? So mode is the value that occurs the most often. Okay? So in our first data set here, 3 happens the most often. So our mode is 3. Over on, when we add in the data piece that was 10 hours, the mode is unchanged. So if you're looking for an advantage for mode, it's the same as the median, right? Where outliers really aren't going to affect it much. The disadvantage is, number one, you've got to look at the data and try to figure out which one occurs the most often, right? Now, outside of that, another disadvantage to median is that there's not a whole lot more calculation you can do with it. There's nothing else that we're going to be able to do statistically speaking that is going to be very beneficial. So it's nice to understand that the median is where half of the observations fall below it and half the observations fall above it. So it's a typical value, but there's no more calculations to do. Mode is the same way, right? Mode is, okay, you take a look and see which data piece occurs the most often. So that kind of gives you an idea of a typical value. But outside of that, we do nothing with the mode. There's nothing else to do with the mode. It doesn't really tell us anything else. So it's not very useful. The advantages, again, it's like the median where, again, like I said, outliers don't affect the mode. Unless you get a bunch of the same outlier. And then it can really affect it, but then it doesn't become an outlier. So it's just, the mode is even used less than medians. So good to point out, but not very good to practice with, right? So with those advantages and disadvantages in mind, which one is better? Which measure, mean, median, or mode, would you want to use if your distribution looked like this, right? So this is a frequency distribution. It's a histogram, and it's taking a look at ages of students in a class, right? So this is the class at IU, right? Now check out, you've got one student who is what's called a non-traditional student that is 65 years old, right? So mean, median, or mode, which one's going to give you the best measure of central tendency, which gives you a better idea of the center of your data, right? And so hopefully, I hope you're thinking the median will, right? The median is not affected by the outlier. There's that one outlier. And the mean is, and you can even see where the mean, the graph shows you where the mode, the median, the mean sits, right? Because of that outlier, the mean gets pulled all the way over to the right. That's not really the measure of the center, right? We have more data pieces that are falling in that first interval. So our mode is going to fall in that first interval. And that's not really showing us where the center of our distribution is either. And so the median is falling somewhere right in here, which is basically in the middle of our distribution if you don't take into account the outlier, right? So the median is definitely a better calculation here as far as letting you know where the center of that data is. So if you're looking at test scores and everybody in the class seems to hover around 60 to 70%, and there's that one really smart person that got 100, that breaks the curve, that whatever, that outlier, it's going to really mess with the class average. So if the class average is an 85% with that one test score, if you take that one test score out, the average might drop down to about where you scored. So you're still sitting about where the rest of the class is, right? So when you're asking what the average of the test is, think about if the average is really the best measure of central tendency. It may turn out that the median is a best measure. So you might want to ask what the median is. Okay? There you go.